my lesson yesterday and not try to do another hard problem so late in the day, but I'm sometimes not good at learning lessons, and I would also hate to not stream. I want to try to do something every day, so yeah, you will have to bear with me for another hard problem that I don't have enough time to solve. So only the next 25 minutes I have for that. Okay. So under the can below, strings can represent a set of uppercase words. Single letters represent okay. So we are given a string. So expression string, I guess, and we need to return a list of strings and tests. So there are essentially two operations that can happen. Yeah, we are given a good test here. Not very good. Let's complicate it a little bit further. So let's say we also have C, G, and then DE. Okay, so what would this give us? We always start with A, and then we do either B or C, right? B, B, C, C, C. So it can be B or it can be C. And then we look at this expression, and it also combines to other expressions. So first of all, each of these, it gets combined because, oh, this is concatenated. No, we want not concatenated, we want this. And I'm hoping that inside, like, I can only have those expressions delineated by commas. I'm not sure if we can have more letters or if it's just one letter. But okay, so we have B and C, and here we will have either C or D or E. And then here we definitely have F. And then here we have G or H. So what does it tell us, right? It's kind of a backtracking problem. And I'm probably missing something about this because it's relatively hard. But it looks like we open the bracket, and in the opening bracket is basically multiple of the things that can happen under the hood. And then we are just choosing from all of those things. And yeah, so if we are combining a few things, then we just take like a union of two sets. So it feels like we can create something like this. Obviously, we can have deeper combinations. Like what if we have more depth? Let's say A, then B and C, and then D and E, right? So how will this work? We always start with A, and then we do... Is that something that can work? Or do we need to first... Like, do we have to put this in the brackets? I'm guessing yes. Okay, then... Yeah, then the depth will be something like FG, right? So D and FG. So we start with A, and then for the second place we choose either B or C. But then for the third place, we now can choose D, and then after that we can choose F or G, or we can choose E, and then also we can choose F or G. So there is some branching here, but it's no different than just doing this, right? And we still have all the pains from trying to parse this, but we are just opening the brackets. So once the brackets are closing, we have a list of possible things that we can iterate over and try each option and continue until we get the next bracket. And the only thing is that if we have a comma, we first need to continue traversing until we get the closing bracket without the comma afterwards. And at this point, we can just start iterating over all the elements. So when we are returning to the upper level, we can just return the list of all the possible combinations. And if we also need to have those sorted, then each of those sublists needs to be sorted as well. Okay, we have discussed the solution. The implementation will be backtracking. So how do we figure out the runtime complexity for this? We will be creating new combinations, like for any bracket, there will be all the possible combinations. And then we are basically multiplying all of those combinations. So it will be O of n times m, where n number of letters inside brackets and m number of brackets. So yes, there will be an exponential running time here. Now implementation. I see a new message in the chat. Give me a second. Buy a different time to stream because I didn't have time to stream earlier today and I still want to stream daily. And I'm already exhausted, so I'm not at my best right now, which is also a good thing because I'm training to deliver whenever I'm solving the problem. Okay, so how we will be parsing this? So there will be either an expression, okay, so process element, and if it's a bracket, so it returns either an element or a list. Process element, which will be a function, and it will be pointing to a specific place in this expression string, and this will be an integer, and it will be returning several things actually. So it will be returning tuple, and the first thing will be either a union or set or string, and it will also be returning integer. So what do I mean by this? We will need to return, so let's say we are pointing at some place here. So we're pointing here. So here we want to just process this and return an element A. So let's say B, then we are just returning B. So then if we process the element and it's an open-end bracket, we start go one level deeper in this function and we start processing it. And then it's B and then it's C. And at this level, at the level of this bracket, we will be adding all of those elements to our set. And if we are encountering closing bracket, we check what's happening afterwards. If the next thing is the comma, we're just continuing iterating over brackets and adding to this set. Yeah, I'm interested what would happen if we have something like A, B, C, D, D, F. How does the grammar work in this scenario? Are we required to also have brackets like these? If yes, then it's fine and we will be processing things correctly. I hope we are required. Okay. So we are processing the element at this particular point, and I'm just thinking about how do I want to later concatenate everything. So ideally, here I'm just kind of like doing it differently. I want to return things and then iterate over the things that I have returned. I probably want to do something different because it becomes too complex. So here in processing the element, I don't want to return this, everything like this. Let me just try to return the integer. And let me also store the current sequence. But yeah, the problem is that we will be going back and forth and adding all of those things. It would be easier just to like multiply things. No, we still have on the order of the answer operations. We cannot do anything better than that. Okay, so current sequence will be this, right? So if I'm processing element and it's just a letter, then I'm adding this directly to the sequence. Otherwise, I'm adding this to a local list and then I iterate over all possible elements. Current set will be equal set. And okay. If expression at I is not an can we just make it is not equal to the opening bracket. So the invariant here that we can either get an opening bracket when we are calling this function, or we are getting a letter itself. So if it's a letter, we just do current sequence append. Oh yeah, if we just append it, we need to also like do all this possible variations. So we need to append it and then backtrack to the previous steps, right? So I want to make it a recursive call. Because I want to do backtracking, so I'm not doing this. I just do append expression I, and then I do process element of I plus 1, because we can only get like either a new letter after this, right? So if we are processing letters, can it just be C? I'm guessing we can never have something like A, B, and C, T. Something like this is not possible. We always have just one element. If not, yeah, actually, even if we have this, my solution will work. Okay, so I have just 2 minutes left. Unfortunately, I won't be able to finish this. So we process the element we need to do here. If I bigger equal length of the expression, we just append the current sequence to answer and go back. Okay, yeah, I have to drop. I had fun solving this problem, being tired, but I think I'm close to solving this. So let me stop the uploading and see you next time.